Welcome everyone to this AI ethics seminar with Didem Gürdür Broo from Uppsala University, where we'll talk about sustainable and human-centered intelligent systems. Didem, please, the floor is yours.
Thank you, Ole. I will start with sharing my screen. And I hope it works. Perfect. So first of all, thank you very much, Ole, for inviting me for this, and thank you everyone for joining us today. As Ole already introduced, I work for Uppsala University, and I'm also the director of Cyber Physical Systems Lab at the university. We work with intelligent and autonomous systems. My research generally focuses on interoperability, sustainability, and complexity of these systems. And today, I want to talk about a project which is called Sustainable and Human-Centered Cyber Physical Systems, and the framework that we built as a result of this project. But before presenting you the framework, I want to talk a bit about the shortcomings of oversimplifications in engineering design, generalizations, and some fundamentally wrong assumptions that we always do when we think about these big complex systems. So my aim today is to introduce some ideas about how we can think, act, and design the future intelligent systems differently. And this talk is quite personal because I see the world from my own perspective. Sometimes it works if we are thinking similar and we viewing the world from the same perspective. As if they are not, sometimes it doesn't. But I hope at least I can initiate some interest, let's say. So I want to first talk about a brief history of industrial revolutions, just to set the scene, to see where we are and how we came here. Then I will introduce you a few examples of cyber physical systems, because I already mentioned the term cyber physical systems several times, but I describe what I'm talking about. And I will talk about data, because it is the driving force behind the success of these systems, intelligent and autonomous systems. It is also a relevant place to start the discussion, because many of us either already works with data intensively, or we hear about the promises that data and artificial intelligence is making. If nothing else, we are bombarded by the hype around them. So I think it might be interesting to start from data as a resource. I will briefly talk about 3 different mindsets that can help us to design future intelligent systems fundamentally different than how we are doing it right now. And that is related with the framework that I will give more information, but that I mentioned just earlier. So before concluding the talk, I also want to talk a bit about my co-design experience with generative AI, which was part of using this framework, and share with you both positive and downsides of this co-design process. So let's start with a short history and look at a series of industrial revolutions that changed the world. The first industrial revolution was essentially started when we discovered how mechanization, water, and steam power can help us to do all kinds of interesting things. Then from the late 19th century into the early 20th century, mass production, assembly lines, and electricity advanced manufacturing and production. This enabled the widespread adoption of technological systems, and that was the time that we decided to call this revolution a technological revolution, which now sounds funny because it was just electricity and basic assembly lines. But later, at the beginning of 1950s, the third industrial revolution brought semiconductors, computers, and automation. And we call that one the digital revolution, which still is funny, because if that was digital, what is this one, right? Today we are experiencing the fourth industrial revolution. We call it Industry 4.0 sometimes also. We have interconnected systems through the networking technologies. So it is evolving at an exponential rate rather than linear pace. And it is disturbing almost every industry all over the world. And this new era is called cyber-physical systems driven. And these systems are integrations of computation, networking, and physical processes. We also have feedback loops between the computations and the physical processes, where the physical processes affects the computations and vice versa. At the same time, we are, and perhaps first time in the history, we are now already talking about the fifth industrial revolution. It's also called Industry 5.0, and Japanese calls it Society 5.0. Where we include social and environmental considerations, and we strive to build human-centric and sustainable, resilient systems. And I think the reason behind that we are talking about Industry 5.0 is that finally we understood that every time we have industrial revolution, every time we have some technology or a driving force that is pushing industry to exponentially grow, we also have after effects of this. So this time, especially in the European Union, we decided that while we are doing this, let's focus on how we can also manage the future of the next industrial revolution and plan it accordingly, so we don't at least need to deal with after effects as badly as we have been throughout the history. So cyber-physical systems is, I'm sure you already understood it. It is an umbrella term that we use for different types of systems. They can be big or small. For instance, integrated transport systems that share information between different modes of transportation are an example of cyber-physical systems. Autonomous vehicles, such as cars and drones, can be also seen part of integrated transport systems and themselves as cyber-physical systems too. Any modern car is actually, they don't need to be autonomous, but any modern car also take, because they are equipped with hundreds of electronic control units, are able to make autonomous decisions about small things, but yeah. And they are also called cyber-physical systems. Intelligent robots working in autonomous warehouses where different types of robots collaborate to fulfill some supply chain related tasks are examples of CPS. And smart factories equipped with Internet of Things are also. This list goes actually like smart cities, smart infrastructure, and so on. Any physical system that are run by software, and there is a feedback loop between the software and physical processes are examples of this system. Cyber-physical systems are promising to change how we live, how we work, how we move around, and even how we think about the services that we receive from our municipalities, for instance. They are also products. I'm sorry. I am sorry. I was a bit sick last week, so I think it comes and goes. But hopefully I will be able to continue. So yeah, these systems are also products of multidisciplinary engineering efforts. That means that no one engineering discipline is able to produce these big systems. We have to look at these systems from different perspectives and collaborate to make them successful. So I am lucky enough to spend years to do research on many of these systems. I traveled with autonomous cars. I followed by intelligent drones. I built collaboration between robots and humans daily as part of work in my lab. I programmed some functionalities, identified some requirements, and I've been part of several big and small projects, listened to people from academia and industry to talk about these systems and not agreeing on anything because we are coming up from different domains and have different aims and goals and priorities. So while the cyber-physical systems, I'm sorry, while these systems are expected to be connected, autonomous, intelligent, the engineering teams, designers, software, hardware developers are not expected to change in a revolutionary ways. So to showcase this, I will give you an example and let me introduce you this guy that is disrupting all engineering disciplines for some years now who are involved in designing cyber-physical systems. Data. Many calls data is the new oil. I hope that we can find a better metaphor and create a brighter future direction for data. Even though the oil-driven revolution, yes, fueled many industries and helped the world to advance, but the waste of this revolution, the greenhouse gases and their effects on climate change, is the biggest problem that is threatening the future of this world. So when we look at some instances, even the very mature technology providers who are leading the data-driven revolution are having difficulties to deal with the challenges around data. As a result, chatbots are turning to races, autonomous cars are running red lights, and many are spending incredible amount of investments and time to short-term solutions. I will try to explain 5 dilemmas of the data that I came across a lot doing research and collaboration with industry. And I believe that these are also some of the root causes of these unfortunate events. The first one is about collecting data, but in a sustainable way. Collecting enough data while considering the privacy, security, anonymity, storing the data, but not consuming tremendous amount of energy. Currently, we are collecting everything, but we are not using what we are collected. It may sound surprising, but 80% of the collected data today is unstructured data. 55% of it is called dark data, which means that we did not deliver any value from it. The second dilemma is more about sharing data. This one surprises me a lot, especially industries and organizations that are not really fully digitalized, asks this question at the end and or may never ask it. Who can I share my data with? How can I make my data available to others? How much, how long sharing? Sharing or not sharing? I will take 1 second. As I told you at the beginning of this, when I was introducing myself, I work with interoperability, and maybe I am biased because I see the world from that perspective. But I think that the real value of cyber-physical systems, which I believe also can make the world a better place, can only be achieved if we have interoperability between different systems, if we share data between different systems, so we can derive better decisions because of these integrations. And that cannot be possible if we don't already think about how we are going to share our data, with whom, how long, how much. Volume of the data. Trusting data is another example. We want to use data and learn from it. But can we really learn from data without checking the quality of it, or can we trust what the data tells us if we don't know it is high quality data? This also includes considerations related to responsible data and ethical use of it. If we don't check this trust-related metrics on our data sets and be sure about the quality, I also don't think that we can trust the results that we get. Volume of the data, it's a kind of a very old problem, yet it is still valid. Not only high volume of data is very resource intensive, but also sometimes narrow data sets are more effective and certainly less resource intensive, also can be informative, more informative than complex big data sets. It takes lots of energy to think about well-thought data models from the beginning, and I understand that it might be challenging. So it's easy decision to make, let's collect all the data, but we need to find a way to balance this. Last but not least, the role of humans in a highly intelligent data-driven processes is an important point. How much to automate it, for whom, how to control the automated decision-making through artificial intelligence, for instance. There are some discussions about the whole life cycle of data for artificial intelligence applications, from how it is collected, labeled, how algorithms are trained, to how the resulting services are used. But it is not enough, and not everyone is included to these discussions. So we need to find a way to deal with this also. At the beginning of this talk, I mentioned that the cyber-physical systems are intelligent, autonomous, and connected. We also talked about that the world is getting more interconnected, change is occurring very rapidly. With Industry 5.0 as a goal, these systems are not only expected to take smart decisions, but do it in a sustainable way. As the examples I gave from data perspective shows, just providing a solution is simply not enough anymore. We are required to think bigger, more systematically, find more human-centric ways, and prepare ourselves for different outcomes in the future with good strategies. Otherwise, we will continue to wrap the next generations, put the emphasis on wrong goals, and continue to contribute to the problem instead of being part of the solution. So all these pushes us to shift our mindsets. One of our research projects is focused on this. We developed a transdisciplinary framework which can be used as a tool to design the future intelligent systems in a more sustainable and human-centered way. The framework is an attempt to guide engineers and computer scientists to design these systems, firstly by considering their systemic effects and relationship with other systems through systems thinking, employing human-centered design and putting people at the center of design and development processes by design thinking, and having a long-term perspective by looking at different signs of change that may shape different possible futures by futures thinking. I don't have time to go through them in detail and explain you how they work, but I will try to explain at least how they can help us and what kind of a shift they initiate in our thinking. The good news is that we will facilitate a few workshops in February and March, where we will introduce this framework in detail and help the participants to use it. At the end of this, we will also design several prototypes, and we will use generative AI tools to do this prototyping process. So if you find this interesting and would like to learn more, please contact me so I can send you invitation for these workshops. As we discussed, the cyber-physical systems are connected systems of systems or ecosystems. When we approach engineering problems, many times the first instinct is to divide the big problem to smaller parts and solve these small parts. This decomposition or divide and conquer approach is an effective way that actually helped us a lot. When we look at engineering history, it is full of stories that we divided big problem to smaller parts and we were successful. But in this century, when we are dealing with systems like cyber-physical systems, which are not only complicated, but they are complex, and we are aiming to address challenges like sustainability, which is also a very complex problem, this divide and conquer or decomposition approaches are just not enough. So systems thinking is a great methodology to support us when we are working with this kind of systems and problems. It helps us to understand the whole system and guides us on identifying different dynamics between the parts of the system. It intentionally moves our mind away from disconnections to interconnections, from linear thinking to circular thinking, and from silos to emergence. In systems thinking, we value relationships and synthesis more than isolations or analysis. The shift here is from simplifications to complexities. It's a completely different mindset that teaches us to stay focused on the reality and understand all the complex, difficult relationships around this reality. It still aims to solve problems, but puts the emphasis on understanding the bigger picture before diving in to provide solution for it. The other methodology is about human-centered design and design thinking in general. Design thinking is extremely useful to tackle complex problems that sometimes we also call as wicked problems, because there are so many interdependent factors and changing requirements, we call them wicked. And design thinking serves to understand the human needs involved, helps us to reframe the problem in human-centric ways, and create numerous ideas instead of focusing one idea, develop rough prototypes so that you don't get attached to your ideas and the solutions. You can let them go very easily. And you test these rough prototypes with real users to collect feedback before diving in and producing more sophisticated solutions. Design thinking process proves us that the technology is a tool, it's not the goal, which I think is a great need for this century, because so many times I see so many projects that are basically structured around using one technology. And then we forget to ask, but what was the problem? Who am I going to help with solving this problem? And how can I involve these people so I can solve the problem for them? We just want to use this very new, shiny technological product or approach, and unfortunately, sometimes even make up problems. In this methodology, the shift is away from conventional repeated solution towards ambitious questions and user-centered innovations. As we saw with the oil example, many of the problems we are dealing today were the solutions of the yesterday. Somehow, we need to be able to look at the future and be able to see different possibilities for the systems that we are designing now, so we can design them in a more resilient way. Future thinking methodology equips us to actively search for technologies, trends, solutions, and decisions that has the potential to affect the future direction of our systems and all the other systems that they interact with. I want to highlight that it is never possible to predict the future, and that's not the aim here. We don't try to predict what is going to happen in the future. We just try to understand what kind of different future possibilities are important for me to consider my system. The goal is to improve the ability of thinking long-term, build strategies, and design our system around these strategies, so at the end they become more resilient. And here the shift is away from immediate fixes towards long-term divergent possibilities. So I will give a brief example of how we can use this framework together with, for instance, generative AI. My lab specializes in designing cyber-physical systems that are inspired by nature. We typically design these systems through an iterative process that includes brainstorming, sketching, computer modeling, simulations, and so on. A typical engineering design process. Generally, we start with as a meeting as a team and come up initial concepts. We talk about the system's intended purpose, constraints. We create, as I said, sketches and simulate some CAD models to see and analyze dynamics, refine some mechanics, and then we build simplified prototypes for evaluating before constructing more polished working versions of these prototypes. This process is collaborative, but it relies heavily on the designer's past experiences. And in every step, we limit our design possibilities further and further. And there is a reason why we do this, why engineering design process is designed this way, because we want the end product to work. So that is our main priority. And that's engineering mindset, basically. But we also learned that because the world is changing so fast, especially when we are working in a technology domain, what doesn't work today may well work in a month or two, or year or two. So there is this dilemma between doing something, creating something for today, which will not be relevant in very short time. And we wanted to tackle this and try to understand how we can use different tools together with the framework to help us to generate ideas, maybe not 100% possible to make it work today, but we can work on it and make it work in a few years. So we decided to try something new, and instead of aiming to limit ourselves for the designs that we are sure that it will work, focus on what we ultimately want to achieve. We envisioned the jellyfish robots collecting microplastic from the ocean and acting as part of the marine ecosystem. They have their own ecosystem, but also they are part of the bigger ecosystem. And this was decided as a result of going through the framework, as I said, using many tools from systems thinking, design thinking, and futures thinking. We discussed what we care about most, what problem we want to solve, and how this particular problem interacts with other systems, like social systems, environmental systems, and so on, and who our users might be. So at the end, we considered sustainability and resilience as the key goals for this system, and we started to ideate. As I said, I wanted to try if we can use image generators, for instance, to help us to create these rough prototypes as images and show up or open up possibilities we had yet to imagine. And here you can see different designs for this jellyfish robot that is created in collaboration with an image generator. So co-designing with an AI was for me a very interesting experience. Image generators are generative AI tools that read a text and use large language models and a huge amount of image data to generate new images. This input text is called prompts, and a prompt can cover many attributes, including subject, medium, environment, color, mood, even. I learned that a good prompt needs to be specific, because at some point I wanted the design to serve a particular purpose. So you need to know what you want very well so that you can describe it. On the other hand, during other stages of the design process where we were more interested in ideation and explanation, we wanted to be surprised. So we used different techniques to achieve that. And I discovered that I needed to strike a balance between what I knew and wanted and what I didn't know or couldn't imagine but might want, which is a very interesting way of thinking and working. Normally, we don't work this way. For instance, there is a parameter called chaos, which I loved. When we explore different possibilities, I wanted images to be generated in a way that they do not have a lot of similarities with the earlier images. So that time I used very high chaos parameter. And we generated many images according to our discussions and what we were thinking about. These, for instance, organic shapes in the AI art sparked useful ideation, and we decided to do further research and exploration about what might be possible and who we need to collaborate with to see these possibilities. This is also an important outcome, I think, because as any engineering designer knows, it's quite tempting to start to implement things before you do enough exploration. And these fanciful, maybe impractical computer-generated concepts can be very beneficial at the early stages of engineering design, as serving rough prototypes, for instance. Of course, the use of AI image generators also raises serious ethical issues. They risk amplifying demographic and other biases in training data. Generated content can spread misinformation and violate privacy and intellectual property rights. There are many legitimate concerns about the impacts of AI generators on artists and writers' livelihood. Clearly, there is a need for transparency, oversight, accountability regarding data sourcing, content generation, and downstream usage of these tools. So I believe that anyone who chooses to use generative AI must take such concerns seriously and use the generators ethically. Additionally, when it comes to sustainability, it was just a day or two ago that I read a research which says that every time someone uses to generate an image, actually the energy consumption is equal to charging your phone. So, which is also another thing to consider. But we use this for research and to try out how it can be used, and if there is any possibility where this possibility starts and ends, what we should consider. So I am quite happy that I tried it and learned a lot. I think co-creation with image generators can help us to explore design of future systems. They can help us to shift our mindset, move us outside of our comfort zone. It's completely different way of designing, as I mentioned. And it's a way of creating a little bit of chaos before rigorous engineering design impose order. At the end of the day, we want to make things to work. So that order will sooner or later come. In image generators are just one example that I enjoy to explore, which can be used as part of the framework. There are so many other possibilities also. If you want to read more about the whole experience, you can check the IEEE Spectrum's November magazine. I have an article which explains in more detail this design process and my experience about it. I put the link here. It's in yellow color. So the framework and the mindset, I believe, has the potential to help us to understand how the world is changing, how our systems are interacting with each other, and how they can be designed in a way to benefit everyone. My experience on studying intelligent and autonomous systems taught me the importance of understanding the big picture, stopping the urges to simplify the reality, stepping outside of my comfort zone, and looking at problems from different perspectives. As my former PI from Stanford, Larry Leifer, would describe it, this process is like dancing with ambiguity. I always wanted to make the world a better place. It's an activist and intentional decision to want to change the world. And it starts with changing how we think, how we ask questions, and how we design solutions. In my case, it is cyber-physical systems. This is who I am. This is what I am working with. But in your case, I am sure it is something else. I hope this framework can generate some interesting ideas for you. And I hope at least some parts of this talk resonates with you, encourages you to look further for these three mindsets and learn a bit more about it. And even dance with the ambiguity, who knows? Because I honestly think that this is what the world needs most in these days. So this was all I planned to say today. I would like to thank you again for listening, and I am happy to answer any questions you have.
Thank you, Didem.
Thank you.
I now open up
Shall I stop
the floor for this. Yes, so we can see each other better, the whole group. Yes. So the floor is open. Yes, Gordana.
Yeah, thank you very much, Didem, for a very exciting talk. It's not so often that people are talking about future so directly and structured and with clear ideas. And I have also some connections with interaction design, and my colleagues in interaction design always test their ideas on users. But when we think about a little bit a more distant future, not people who are living right now, but maybe more distant, how do you approach this problem? How do you test your ideas?
Yeah, thank you very much for nice comments and the question. So in the future strategy development, we call it, there are several methodologies, and these are scientific methodologies. Really, I know sometimes in some crowds, this is saying that people might think that you look at this crystal ball and guess what is happening. It's not like that. We do a quite rigorous research about different trends that are identified by organizations, governments, states, like European Union, for instance. And there are different committees, groups that does this yearly. There are lots of reports that one can find for 2040 and all the expected trends, we call them, that will happen in 2040. This comes with sometimes with even statistical values. People can even run simulations on this, how these trends might result. I don't do that. We do more qualitative research. We list all the trends that we find, and these trends need to come from different domains. So even though I work in technology, I look what is going to happen in politics because I know that will affect me. So sometimes we identify hundreds of different trends as a first step. Then we look how these trends can affect us, because we start with big and divergent lens, And then we focus on, okay, which one of these we think might change us, and we converge. So the methodology is quite straightforward. I think anyone and everyone, after trying it and working on it several times, can get a hold on it. The more people who does it, the more benefit is there, because we all look at things from different perspectives. So I always suggest to have as big as possible group. In our workshops, for instance, our groups are generally 6 to 10 people. So 10 people for 3 hours need to look at the different trends. And that's so interesting to see how people evaluate and choose these trends and so on.
Thank you very much.
Thank you, Didem. Are there further questions?
I have a question.
Sergey?
Yeah. Hello. So thank you very much for the talk. I have just one probably comment and question as well. So you showed the design of the robot, which was done by probably Midjourney, or I don't know which one you say network you generated it with. But well, design is great, but actually it's very sexy, it's very appealing, but the design actually should follow the technical characteristics that you need from this robot. And say these buttons are fantastic, but will they survive actually the water? So my question is it of much use? So yes, there are of course cases when it is really great. So for instance, I saw and very impressed by say designs of a kettle or bread fryer a la Gaudi. So that's somehow easier to implement, but say make just design of some complicated thing, it's just not enough.
Thank you again for the comment and question. So today, the generative AI and the tool that we use are trained with the data sets that were available with many museums and art galleries and as an open source like MoMA. So surely what they create is, as you defined, sexy. It looks really good. It looks very professional, and it serves a special purpose. In our case, it was for ideation. So we wanted to see what is possible. Surely, I did my PhD in mechatronics. So I have seen lots of working systems that looked ugly, but there is a balance that we need to, I guess, strike. One is to have as many as ideation possible. Design thinking process asks us to do that in very short amount of time. We need to produce as many as possible ideas, for instance. And one can do that just by writing and communicating with these image generators. And then we look at, okay, this is possible. Can I work with that? Or what parts of this looks interesting? I wouldn't think about this perhaps. This is for ideation, basically. Another point of using generative AI in more structured way is, for instance, when it is embedded with CAD design. For instance, NASA has been using generative AI, and I talk about it in my article also, to produce much more constrained specific bolts or parts of satellites, where they say that the material usage needs to be decreased 20%, and the model calculates how I can keep the same strength measurements while I am decreasing the material usage, for instance. So when we have more powerful and specifically trained algorithms and models, I think generative AI will have even more use cases. The exploration that I did, I don't think that we will use any of them, except one of them that we use that we were talking about was having a air bubble that we were like, we never thought about this. Maybe we should think about how we can use air to ascend and descend the robot. We will use some ideas, but other than that, I don't think that they are 100% useful.
Since we're talking about generative AI, so I see actually there is another ethical issue. Well, not ethical, but actually an issue with that. Of course, so all these AI systems, they are trained on images in order to produce new images. The thing is that initially they've been trained on, say, images which were produced by humans. Now, actually, most information is coming from actually the images which were produced by AI. So, in a sense, yeah, and of course, it may produce it in much bigger, say, quantities than the humans could. So we are kind of losing actually the handle. So the AI, generative AI systems will no longer need any humans.
Mm-hmm. Yes, you are right. I mean, there is it is called synthetic data, which is not data that we produce, but it is data that is produced by another AI system, or sometimes same AI system. And it can go really wrong also, I think, because like every time, I don't remember, it was someone was saying that if you have a JPEG file and you make it bigger 1,000 times and then try to use that and make it smaller, the resolution of that too is not same. You cannot reach back to that same level. And then that resolution is existing currently with the data also. So we cannot have the same level of resolution, same level of details. But also there are also other type of initiatives that are giving, even I received some emails, for instance, the 2 kronos for every photo that I put, and it can be photo of anything and everything. So people are also trying to do that. Apple is now putting LiDAR to the phones that will collect all this LiDAR data, which is 3D data, and so on. So I think so many initiatives are focusing on collecting more and more data about anything and everything. And as I mentioned in one of the slides when I talked about the challenges around data, I don't know if this brute force method is enough or even efficient or helpful. I think that like why the framework is important to me is that I think we have enough technology to solve so many problems, but we are not hearing the problems. We are not prioritizing problems in the right order, right? That is another perspective that I think is important to bring. What we are trying to achieve. We have all this technology, but also we are having so many difficulties. People are in different levels everywhere in this world. People are suffering, and technology can be a solution to many things, but it is not. And why is this happening?
Thank you very much for your comments.
Thank you. Thank you very much for the great questions.
Thank you, Didem. Are there further questions or comments? I have just this workshop you will be running in the winter, you mentioned. What is the target audience for this?
It's very interesting. So we want everyone and anyone to be in the room, because we think that if we are going to build a next intelligent system, I even wanted to include kids, but I need to get specific ethical approvals for that. Not just professional designers then? No, certainly not. We want to bring engineers, philosophers, any students that I can get from Uppsala University. I will announce it everywhere, from medicine to, and also people outside of the university, if I can, different ages, different, as diverse as possible is our aim actually. So I want to encourage everyone who is interested to visit us in Uppsala, hopefully.
Oh, thank you.
Thank you.
Anyone else has a question or comment?
Yes.
Ahmed?
Yes, it is Ahmed Bahrawi here. First of all, I would like to thank you very much about this very interesting seminar. I totally agree with you. These ideas, to some extent, I was thinking about a long time now, even within different area, within EE, but in other areas as well. I highly recommended you to think more about evolutionary approaches, about robustness, and about multi-objective, multidisciplinary way of dealing with complex systems. I submit a link in the chat. Please take part of information there.
Okay.
It could be helpful for both of us.
Yeah, that would be great. Actually, I am working on a research idea which I talk about symbiotic cyber-physical systems, which is very evolutionary. And I think one of the reasons that we wanted to look at this robots like jellyfishes or so on was the nature. They say that the unsuccessful natural attempts,
Yeah.
we don't see them, they are the fossils.
Yeah.
Everything and anything that we are seeing today in the nature are very successful. So we can learn a lot from that. So I look for biomimicry and so on. So I will certainly look at the link.
And we will have to consider that the context is always changing.
Yeah.
This actually is evolutionary approach as well. This kind of dynamic optimization over time. So please get in touch and please send me the invitation to your seminars or workshops in the future.
Yeah. I will try to get emails, or you can send me an email. I don't know how to reach you, but it would be great. Yes, please. I will be very happy.
Please.
Thank you very much.
Thanks a lot.
Thank you.
Wonderful. Any final question or comment? Well then, thank you, Didem, for this
Thank you very much,
most interesting seminar.
This was a pleasure. So happy to meet all of you, and thank you very much for the nice discussion.
And thank you for the
Thank you.
hopeful perspective.
Thank you.
Bye.
Bye-bye.
Bye-bye.